Bob from Oregon's Constant Gardener. Welcome, my YouTube buddies, to the OCGFAM show. I was just checking out this Smart Humidity, a special report. Quest Dehumidifiers, they put this out, did a lot of the information. And Santo Bonelli from Quest Dehumidifiers was just here. He just left a minute ago, and we talked about dehumidifiers, but more importantly about how in the environment of your grow area affects your ability to grow plants, how much they can uptake as far as nutrients, and how the resistance they can be to pests and pathogens. So anyway, it's a long one. It's a long one, but I think it's pretty interesting. It's about an hour that we were just standing right here talking. So check that out. I hope it's interesting to you. Look at that, and then I'll talk to you after. Hey there! Bob from Oregon's Constant Gardener here with Santo Bonelli. Quest Dehumidifiers.
How you guys doing?
What do you got here?
This is a Quest Dehu. This is actually the 110. This is one of our smaller units. And so
even your small unit's a big unit.
Yeah, even this is still made for small or light commercial.
A commercial type growing at scale kind of situation.
Yeah.
So why would I need a dehumidifier?
Dehumidifiers are essential to regulate the humidity in your indoor garden or your grow space, your sealed grow space. That could be a greenhouse as well. And it's to alleviate excess humidity, again, and to regulate humidity. And those, what you're doing with your dehumidifier is putting your plants into a zone where they can better and more easily transpire. You're also putting your environment into a position where you're going to help prevent propagation of molds and mildews. So, in essence, an effective part of your IPM, integrated pest management type program. They're also good for sustainability. Especially our dehus. So the evaporated coil on our dehus are E-coated, and so essentially that means you can use the condensate or the water, reclaim, and use that water to feed your plants, or to use it in a humidifier. If you're running sort of like a VPD type style, or if you're potentially using it for propagation or vegetation or vegetative stages.
Okay, got some questions for you now.
Yep.
So transpire, what's that mean?
So when essentially transpiration is the plant's way, it's the plant's way of cooling itself off. So it's pulling water from the root zone all the way, from the media, all the way up the stem and out through the leaves, and in the form of water vapor. And so that creates, in a sealed environment, that creates a humidity load.
Okay. So is that not unlike how we as humans perspire?
Yeah, I guess in a sense. Yeah.
So it's not so much part of the plant's metabolism as it is the plant's way of cooling itself to keep it at an optimum temperature.
Yeah,
and where it can. Okay, go ahead.
And with that, it's pulling nutrients up through its stem, through its system, through the various tissues.
It's not exactly a wicking type situation, but you could think of it that way in your mind, that it's dry up here and it brings the moisture up kind of situation.
I guess, yeah. If you're thinking it in the sense of higher and lower humidities, right? In order for the plant to transpire, they must be set into, they must be in a humidity zone or range that allows it. If you're in a range where the humidity is too low, or you have a VPD deficit that's a high VPD deficit, right? Or vapor pressure, in other words, vapor pressure deficit, the plants will effectively close their stomata and struggle to transpire at all. And that could lead to soft tissues, guttation, diseases. If it's too high, VPD low, right? Yeah. So the humidity in the room is high. The plant would have difficulties also transpiring as well in those conditions that can also lead to nutrient or mineral deficiencies in the plant.
So it's not just as simple as the temperature, because I would assume, as someone who knew nothing about it, that if the plant's trying to cool itself off to a certain temperature, that I have an air conditioner and I have all this stuff, I can make that plant that temperature. But if I make the plant the temperature it likes, but it doesn't have the right humidity, it's still not happy. Is that correct?
It's still not happy. So VPD is a measure of how the plants feel. And
okay. So there's a combination of the two, of the temperature and the humidity?
Yep.
And so my understanding is that it's a combination of the temperature and the humidity in the room versus the temperature and the humidity in the plant itself.
So yeah, it's a combination. I mean, when we talk about VPD, there are various ways of measuring VPD, or elements, I should say, components to measuring VPD. There's one element is to take the room temperature and the room humidity, and the other side of it is to actually take leaf temperatures and then the leaf humidity. Typically, you'll take leaf temperatures at the canopy. You'll measure those leaf temperatures, and typically the humidity is saturation point in the leaf for 100%.
It's always 100% humidity in the leaf unless there's something going wrong.
Yeah.
It's got a problem.
It's got a problem.
So for the most part.
Yeah.
Okay.
Yeah. So what occurs in these situations, and this is why you in like cloning and propagation, you see higher temperatures and higher humidities, right?
Okay.
Because you do want to slow that transpiration down.
I gotcha.
You don't want. You want the clones to be able to form roots. You don't want a clone to dry out because of the lower humidity in the room.
Oh, it's more fragile at that point. So I guess if I'm 98 degrees, but when I go out in 90-degree heat, I start overheating because my body's naturally producing heat just like that plant's naturally producing moisture. And so when you put it in a very moist environment, it can't get rid of that moisture, whereas if it's in a very dry environment, it might get rid of too much moisture. Is that a similar? Is it
yeah, I mean, So in a very dry environment, it depends on how dry it is, and so if it's dry to the point where the stomata close, then it won't be able to get any moisture out, and again, you lead to soft tissues and diseases, and again, guttation, where the plants are trying to push the moisture out through little pores in the surface, not the I guess maybe the specialized stomata in the surface leaf tissues.
So what you're saying is that the plant gets all mushy and it makes it very easy for bugs to get in there.
It makes it very susceptible for molds, like in dry situations. So you'll still see things like PM, botrytis in very dry situations because your plants are stressed or potentially sick or lacking, because of lack of uptake. And just like in high humidity situations, right? So if the VPD is low and there's a very little disparity between the room humidity, the room conditions and the plant conditions, then it's harder for the plant to transpire. And so you could still, obviously in the high humidity conditions, it will still lead to things like molds and mildews or botrytis and PM. So understanding your plants and finding that zone that the optimal environment for them is incredibly important.
Which would not necessarily be obvious, because in my mind I would think if it's very dry, the mold can't flourish.
Yeah.
But it's not very dry on the plant.
No.
And that's where the mold's happening.
Yeah.
And so it's not just a one-to-one kind of situation. You need to work with the plant to get what it is looking for.
Yeah. And I think like we talked about earlier, we talked about like how plants have evolved for certain climates, and this have so understanding
desert plant versus a jungle plant, I gotcha. Okay.
Yeah.
Okay.
So what they prefer and what their optimal environment is part of understanding that, because again you can use these methods for all sorts of plants, but you can use them incorrectly as well. I mean, it can be a tool to benefit you, or it could be a tool that lends more harm to your environment.
Okay. And so we wouldn't necessarily want to try to perfectly mimic nature because we're in an enclosed environment.
You can, but again, with any of your tools in your grow room environments and greenhouse type environments, there's a limitation. You've got to realize the limitation with your equipment. In some environments, for most plants, you can get optimal conditions within a greenhouse or an indoor gardening environment. Whereas some plants you might not be able to to perfectly replicate the environment.
But I guess you wouldn't want to be too locked down to a certain. I want to be at this temperature and this humidity, because there's probably a range of temperature and humidities that
most plants have a range. They're very forgiving within those ranges.
Okay, so I guess what you're saying is that you probably want to first of all try to get an idea of about where it should be, put it at that, and maybe do some experimenting with what's more effective or less effective to save yourself money and to make your plant more effective. And that measuring vapor pressure deficit is a tool for doing that.
Yeah.
But not necessarily the first one you use. You just kind of want to get into some reasonable range and then kind of work from there.
Yeah, I don't recommend it right off the bat. Using it right off the bat. I mean, it is something that more experienced horticulturists or growers, if they want to, should be using if they want to.
So, and you'd say, like, in most environments, it's probably, if you're an indoor grow, it's probably too hot and too humid for the most part. Who knows where you're at? You might be in a winter environment and it's too cold in your grow. But most things you're going to need to dehumidify and cool off your environment.
Yeah. So I mean, again, with a sealed space, so that's where dehumidification works best. It's you can't have a dehumidifier. Throw it outside and expect it to work. Especially in the greenhouse situations. If you're a greenhouse grower and you want to have dehumidification, if the greenhouse is not sealed, there lies a problem.
Like you got leaks in the thing where you got air leaks and stuff that's coming in. You may be overwhelming your unit with the outside.
Yeah, with the outside humidity.
I gotcha.
And so a lot of times with the greenhouse situations, we talk about conditions, like numerous conditions, but we try and oversimplify things. We try and simplify things by having a couple different scenarios, like your daytime, especially here in Oregon, right? The summers get really dry.
Sure.
So effectively during the day, you can exhaust or vent out
you don't need
your humidity.
Yeah.
But at night, when the temperatures drop and the humidity might actually be higher than the humidity inside your greenhouse. Pulling that humidity, exhausting to exhaust your humidity out might actually not be the best game plan for you.
Okay.
So being able to seal up your greenhouse and close, vent up, close up the louvers on your exhaust system, roll the sides down if you have a greenhouse in which you have sides that roll up. Tightly making it as tightly sealed as possible during those evening hours as the temperatures drop is the best thing you can do for your dehumidifier. So if you're deciding to use a dehumidifier in a greenhouse situation, so many variables come into play. Seasonality of the greenhouse, because again, if you're a seasonal grower, then a lot of times you're growing from the spring through summer through fall.
Sure.
But if you're a year-round grower,
you have different. Each grow is a little different situation because of the outside temperature is affecting your room, no matter how insulated you are.
Yeah, and it depends on the type of greenhouse too, right? So there are all different types of greenhouses. Some greenhouses are naturally well sealed. It's almost akin to having a commercial building, with the clear poly roof, and that you're allowed, and have commercial systems like HVAC systems, and then there are greenhouses that don't, predominantly greenhouses in Oregon are, the type that are vented. You've got poly, and you've got an exhaust fan system type system, and you're venting through, you're pulling air through to get air movement, but also to relieve your humidity as well, and for cooling too, especially when it's hotter outside. So a lot of the times it really depends on the systems that you're currently working with, and then reaching out to us and having us get into a conversation. Hey, to have a feel for which variables we're talking about, and what we can do to help you with your humidity loads at given points in time, whether it be you're a seasonal or year-round grower, or you just need it for like we talked about, that A environment, that day versus night, just for the nighttime applications. So so many variables when it comes to greenhouses.
So a big part of getting this is getting you.
Yeah. But I mean, for the most part, when you talk about dehumidification for a indoor garden or a brew room, you're essentially just talking about sizing dehumidification based on your water load needs. And so you could see how that could potentially be a problem in an unsealed area when you have, again, in Oregon where we get a lot of humidity out this way. If you have an unknown factor, a lot of times that high humidity outdoors is that unknown factor you're bringing into your environment. It's hard to size for those unknown factors, and that's why, again, when we talk about dehumidification in the sense for indoor spaces, indoor grows, we're talking about spaces that are sealed. Again, if you bring in that we size, for a certain volume of water in that garden, that unknown factor is that outdoor.
I gotcha. So the first step is to seal the thing up, but you're still going to want to have some ventilation in there.
If you're in a greenhouse type of setting, it really depends. It really depends again on location. A greenhouse in Oregon is going to be different from the greenhouse in Colorado or Arizona, or where it's a hell of a lot drier. And again, that may vary too. Maybe in Colorado, it's certain times of year that you do have a good moisture load. It snows out there, so there's plenty of moisture load in the wintertime.
So as a general concept, you want to have your room within a reasonable range. But when you get into a more scale type grow, that sort of thing, you need someone that can calculate that out and know the environmental conditions of your particular area and figure out what you need. Because I assume that this unit is good for one, but you may have the same size room in two different places where this is more than fine, and another one you need 10 of these to...
Yeah, so sizing for rooms all really depends on your water volume at given what your target temperatures are, and what your target humidities are. And then with that sealing, so if you, again, dehumidifiers work best in sealed spaces. Can you vent an indoor garden? Yes, but again, that's an unknown. We might need to take in additional dehumidification for that venting. And the same in a greenhouse type space. It's an unknown, but straightforward. It's really straightforward to size for a garden. It's essentially your daily watering volume. If you don't have your daily watering volume, let's say you run a system that runs off a reservoir and you top off every week to 2 weeks, it's essentially what you top off divided by the number of days that top off. So let's say if you top off every week, you divide that up by 7 to get your daily rate, and that's essentially your sizing for your dehumidifiers.
So I know it's how much water I'm pouring into my plants or foliar spraying onto my plants, and then if I have the room perfectly sealed, that's the number. But if I got a leak and there's air coming in from the outside, there's moisture in that air, that's what's throwing me off. Yeah. That's why it's important to have a sealed room to be able to measure and to control.
Now, when you talk about tightly sealed rooms or sealed rooms in general, nothing's airtight.
Sure.
So you're going to have some leakage. We don't take that,
right.
We do and we don't take that in consideration. If it's a sealed room, it's a sealed room.
If there's a flapping piece of plastic that I can see through to see sunlight out there, we got a problem.
Yeah.
But all the little leaks that I can't see.
Stuff going through your door frames or under your door is typically not taken, in calculations or consideration.
Okay.
Again, it's got to be blatantly a big break in the seal in order for us to let's consider an additional load of dehumidification just because you're potentially bringing in moisture by not having, for one example, in a greenhouse, a gravel versus having a vapor barrier, especially when it's wet out, through capillary diffusion and air wicking, you can get rain could be all over outside and landing on the ground besides the greenhouse.
It's coming underneath it.
Because this is the dry space, and wet wants to go to dry, and so those are moisture loads that, again, if you're not sealed, that need to be considered. It's an unknown too, so it's kind of hard to size for those moisture loads. It's almost like kind of a work in progress or practice of understanding that moisture.
I got you.
So you can size for how much the water is going in for let's say 100 gallons a day. And then on those, and I like to size for worst case scenarios.
Sure.
Those heavy rain days, you still have you still have high humidity in those greenhouse type situations. You may need to add, and that's what's great with these systems. They're modular. You may need to add a unit, see where that gets you.
I got you.
Need to add another unit to see where that gets you.
I think I'm fine, but this thing's running 24/7 and still not getting there. There's some other factor in there that we have to deal with and maybe size up.
Potentially some other factor.
Does air conditioning affect that?
In a grow room?
Yeah.
So air conditioning does do some dehumidification as as a lot of commercial growers know. There is and from the HVAC side of things, there is when we talk about cooling, we talk about sensible loads, and when we talk about dehumidification in the HVAC end, we talk about latent loads. Your AC systems, depending on how they're installed, can do various percentages of dehumidification, but by no means should they be your primary source of dehumidification. For a couple of reasons. They're not meant to handle loads unless they're again tuned. They can be tuned various ways for dehumidification, but they're not meant to.
That's not their job. But they do affect it in a positive way, not in a negative way.
Yeah, they do affect it, and they're going to affect it when they're running.
Sure.
So,
yeah.
For them to be, for them to dehumidify the room is again in a situation where there is a heat load, and typically in a grow room, the heat load comes from your lamps.
Sure.
And the AC is running, and it does give some dehumidification. At night, you can run your heat system. You can run a heat or reheat, and then run again your AC system to counter the heat on that, but this is very ineffective. So a better solution to that is to run a commercial grade dehumidifier in your room to alleviate high humidity, to again prevent molds and mildews, and to put your plants in the proper that humidity zone for transpiration. Now again, with that said, again, when you talk about these things, sealed room, temperatures affected, your AC units are going to do this again inefficiently, and again we bring these in for those purposes, because when the lights cut out and the AC stops running, it stops on its dehumidification, and these guys take over. I mean, these guys will be running 24.
So this is always running, but not always. When there's less humidity, it doesn't have to do anything.
Oh yeah. So what occurs is when the lights kick off, obviously you get a drop in temperature and a spike in humidity. Because, as we were talking before, they're levers, right? So if you raise your temperature, your humidity drops. Your relative humidity drops because it's relative to that temperature.
Oh, okay.
And so that warmer pocket of air is an expansive pocket of air. It can hold more humidity. So when you raise that temperature, you're kind of like, I guess in essence, almost like thinning it out, right? And so the moisture didn't go anywhere. It's still there.
It's just not as available to the
because of the temperature raise.
Okay. So why doesn't the air conditioning, when it lowers the temperature, the humidity go up? Because
it does go up. It does go up, and you've got many factors. So when the AC lowers the temperature, you will see your humidity go up. But at the same time, again, it's working.
Condenser is taking water out of the air.
Humidity, it's taking water out. But again, in the same sense, it's not in these situations. In a residential situation, a home or an office building, it might be enough, and that's arguable too. I mean,
I gotcha.
But in a garden situation, it's more so pertinent to have a commercial grade humidifier system to handle the actual load, the humidity load. And so when in my calculations, I've taken a lot of when I do the calculations, I've taken the AC units out of it because unless I have I have what the HVAC installer, or sometimes it's the commercial grower, so they install these mini type systems. Unless I have data that shows me how many pints per hour that it's taking out, or how the system was. I have no ways of solidly knowing what percentage of of the systems taking out humidity. We have averages. We can say, that, based these type of systems we see on the market take out a certain percentage of.
So you kind of guess.
We can guess, yeah. And then these systems, typically your large commercial ducted systems take out more humidity than your smaller mini split type systems out of your mini split ductless systems. But then again, I mean, it can be all over the place depending on how the installer tuned your AC unit. So I've essentially taken, most of the times I've taken those out of the calculations and done the straight water volume calculations. Given
it's not a big enough factor to matter.
It typically isn't a big enough factor to matter. Given your specific temperatures and your specific, like your target temperature and humidity, that's all taken in effect as well for the size.
I got you. So how big a grow do you get before you look at one of these over what you might get at the big box store dehumidifier? I would assume that not only is this better, but it's also far more reliable and far more industrial, and that it lasts longer and gets the job done. That you might buy 5 of those to do the job that break down, and this is going to last long through those.
Yeah.
So where do you get to the point where it starts to make sense to get a real unit?
Right off the bat.
Really?
Yeah.
Okay.
I mean, if you're a commercial grower, you shouldn't be relying on hardware store type dehumidifiers. They're made for maybe your basement, maybe your crawl space, maybe your house. And maybe it will give you the 3 to 5 year warranty on some of these residential type dehumidifiers, but then they break down within a year, and you say, "Hey, I got a 5-year warranty." It wasn't meant for that.
Because it wasn't meant to go all the time. It's like the sump pump in your basement, or maybe the pressure washer you use to wash off your concrete once. If you put that into a commercial thing where they're pressure washing every day, it would not last a year. It would last a month. So something like this. Is this the smallest practical unit?
This we have a 70 pint unit. We have a 70. So these are overhead units. And we have a small 70 pint overhead unit. And then this would be our second smallest unit. This would be our overhead unit. We do have a 74 pint portable unit. I typically make the recommendation with dehumidifiers is to get a hang unit. And the reason why I tell people to get a hang unit is your floor is real estate. So you want to be able to have your floor clutter free and be able to put have your plants on the floor, have your tables, and your stands and your racks and everything. You don't need a dehumidifier taking up space.
Sure. Well, a lot of our viewers are growing 4, 6 plants, not doing it for commercial aspect, but are very particular about their plants being just right. In that kind of environment, does it still make sense to get one of these units?
Yeah, I believe so. If you're growing 4 to 6 plants, and it really depends on the again, your daily watering rates. It's getting into like a 70 pint dehumidifier. It is huge for the home grower or even the micro grower. I know here in Oregon they have micro tiers. Those micro tiers to get the small quality dehumidification system for many facets that you're not constantly having to reinvest in a new dehumidifier every year and a half, because it's not made for that. The other aspect is the efficiency with our dehumidifiers versus those dehumidifiers. So it's build quality, peace of mind with the 5-year warranty that we we give the customers. Our customer service and tech support is phenomenal, and that efficiency piece, like, it's huge. To have a unit in your personal garden that is going to save you potentially hundreds of thousands of dollars a year makes sense to get, versus something that is not made for that environment. It's going to run, that's going to be eating up the costs in your energy bill, and then not only that, but you're going to have to replace in a year and a half once it takes a dive.
Sure. Well, a lot of our growers are growing with inputs that are they're pushing their plants hard, and so they are able to water because the plant pushes a lot more water through it. And so in those situations when you're doing that kind of thing, you have a lot more humidity than you might have if you were just low key on your grow. We'll give it a little water, some minor nutrients kind of thing. So that can be a bigger issue. Do you think that's something a lot of people run into when they start using like Nectar for the Gods or something like that they're pushing a lot more water through that plant? They're starting to get a lot more humidity, and they're used to growing in a the environment before that, where it wasn't such a big deal, it becomes a big deal?
Well, it really depends on the size of the plant and the root mass on the plant. And, so yeah, I mean, plants can uptake quite a bit of water, but again, it depends on the phase of the plant.
Sure.
So when you begin, you might only be, at a pint a day or a couple pints a day. And as the plant progresses, depending on what your intentions are, you could get to a gallon or a gallon and a half a day per plant. It really all depends on your style of growing.
I gotcha.
So maybe with more peat like materials versus a cocoa or something like that, you're gonna have more water retention with those peat like materials. But
so would you say this helps me to push harder in veg and to control mold and things like that in my flower stage?
Yeah.
Those are some of the issues that you can grow a bigger plant in your veg stage because you're able to transpire more water.
Oh yeah, you can regulate. It's again, if you don't, this would be able to, in a vegetative state, right? If you're growing a bigger plant, you have a bigger plant, you're at higher humidities, keeping the humidity in check.
Right.
You want higher humidities, obviously, in that vegetative state, but you don't want humidities that go unchecked. And
I could go too high because I'm watering my plants so much.
Yeah.
And so when I'm getting into those over-humid states, then I bring that humidity down. I'm giving that plant the ability to work more efficiently.
More efficiently, yeah. So again, it's about optimizing your environment so that your plant can help, transpire, effectively and efficiently, and uptake be able to uptake nutrients.
So, and when I'm in the end, I've already harvested and curing, and that sort of thing. Is this something that can help with that too, as far as keeping my room?
Absolutely. In a dry room manner or a cure state, absolutely.
So you'd probably be using like maybe a small moisture meter to measure at the source, and then using this to control your humidity to keep those things drying out or not drying out within that. Does that make sense what I'm saying?
Yeah, you could take those little hand, like the mini hygrometers you're talking about, to measure the room conditions, as you set out a dry room condition. Sure, you can test you can test your conditions. But essentially, when we talk about dry rooms, we talk about starting off with a given wet weight, right? And a duration. So a lot of growers know
where they want to be as far as I want to get from here to here in X amount of time.
So when we talk about sizing for that dry and cure room, it's essentially setting up where would you like your humidity, and how, at what temperature do you dry at, and where would you like your humidity under those conditions, and then what are we starting with a moisture load. When you talk about plant materials, you bring in X amount of pounds, so there's a certain percentage of wet weight in that material.
Sure.
And somewhere around 75 to 80% of that material is wet weight. I like to do straight bath, to be honest with you, because it's just so much easier to say 1 pound of wet material equals 1 pint of water, and 1 pound of water equals 1 pint of water. It's a direct translation.
Sure.
It's easy to do.
Yeah. Okay.
So if you bring in, and I know this sounds absurd, but if you're a bigger commercial type grower, you bring in like 1,000 pounds of wet weight, and let's say your dry time is over a 10-day course. Some guys are longer, some guys are shorter. Then you're looking at again a pint or pound. You got
so you could actually weigh this
over 1,000 pints over the course of 10 days is 100 pints per day. So that's all you would need. So you would dial your dehumidifier in at that whatever your target humidity is at a given temperature, right? And you dial the dehumidifier in, and then it will do its course.
Could measure with a moisture meter, or you could measure with a scale.
Yeah, I mean, initially you're gonna measure with a scale. I think most guys are gonna know where they want to be at the end. They can measure, as things are tapering down. They can measure with their little handheld hygrometers. their dry weight the dry weight moisture or the moisture meters like you were talking about.
So if I got a small grow, I'm pressed for space. Could I veg, bloom, and cure in the same room using this unit?
That unit or 70 pint, yeah.
Okay.
Yeah.
And that's how you would go with a small time thing, is you go full process through it and then start over basically.
Yeah, and start over.
Okay.
And, a lot of it depends again on the time of year. Not that I would recommend bringing in drier air because of all the particulate matter.
Sure.
But there are times of year that again here in Oregon it gets really dry.
And you can have a sealed room because you don't know what's out here.
Yeah.
you don't know. There could be pesticides. There could be someone right next door to you doing who knows what, and you've got those pollutants. So having this can be a real value to doing a cleaner product, not just a better product. There's all kinds of advantages to doing it. It almost seems like I think that you have to control your humidity, and that's the next step as far as someone you set up your room, you have your lights, you have a fan in there, and this is the next step after that, you would think. Yeah. And then let me ask you this though, if you're in an overheat condition, you would have to figure out some sort of cooling before this next step.
Yeah. So and that's something that's so the commercial plug-and-play systems do put back into the environment is heat, but we don't look at it necessarily as a bad thing. I know a lot of growers look at it as a bad thing, but it typically doesn't really come into play unless you're undersized for dehumidification or you're undersized for AC.
Okay.
So heat loads, they're always overstated that dehumidifiers always put heat loads in. And they do. There are some units we do offer a split unit that doesn't actually put a heat load in.
But I guess what I was saying, if you live in Illinois in the summer and it's 100 degrees, 120 degrees, and you have to get your room down to a temperature where your plants can live. That's the step one, I would say, and then step two would be to control the humidity. But if you have a reasonable temperature in your room, where most of us do, then this is the next step. So you just maybe say that it might make sense, even if you're indoors, to grow somewhat seasonally to affect the temperature so that you don't have to go to all these extreme measures.
Yeah. It really depends on your situation. I mean, a lot of things are situational. So it could be that. It depends on your environment, what you're able to maintain in your environment prior to putting plants in. I've had conversations like that too. What is your ambient, what's your starting greenhouse prior to plants? What's your starting room prior to plants? Can you hold these given a system, given your current system, and then bring the plants in there and see what the system does? And then, I mean, I when there's a build out and someone calls me and they don't have all these metrics, I typically tell people, get me these metrics because I need these metrics.
Well, I had a friend that was growing with LEC lights, and they're great for no heat. Unfortunately, he was growing in the winter in Oregon, and he froze his plants because he wasn't prepared for those not to put off the heat. So if you're in a hot environment, you might be thinking about an LEC or an LED or something like that, as opposed to if you're in a cold environment, you might be thinking about some lights that actually put out some heat. Sure. So it's a big picture looking at what the room is that you start with, it sounds like, what the temperature is before anything goes in there, what the humidity is before anything goes in there, and then figuring out step by step from that. Yeah. So.
Yeah, I mean the most important thing, especially for sizing these, once again, is knowing, those keeping your ambient temperatures and how much water is going into your environment. So the starting point is essential too, knowing before you go in, those ambient temperatures. But you're going to size for your lights, your AC system for your lights, and a home grow, it's maybe not so straightforward. You've got your home's HVAC system working for you, whether it's heating or cooling or whatever the case may be. You're growing.
You're controlling the rest of your house. You get some room in your house. So
but with that said, you're not putting into the rest of the house the moisture that you're putting into these plants, and that's why the dehumidification system is essential.
So I guess if someone's got a big giant commercial grow, they just call you up and you'll come out there.
Yeah.
If someone is starting their home grow, what would be some resources or some things they would think about for a small home grow where they're very particular about wanting it just right, but they're not on a scale where it makes sense to get some commercial stuff going. What are the factors they would want to look at, and how in the heck what would be a starting point for this?
Yeah, again, it's about knowing what you're growing. Again, your starting point would be your ambient conditions in your house, your natural ambient humidity conditions, and then what you're looking at, what water loads. If you know what water loads are going into those plants at the worst case scenario, at those heaviest of states, whether it be midway through flower or late in flower, whatever the case may be, and knowing your method, like your style of growing, whether you're more of the hydroponic type style, or whether you're a soil grower, whether you do those if you're growing in soil, some growers have gone straight through without a flush. Some growers have gone through it, heavy volumes of water. So if those are your worst case scenarios, you want to keep that in mind, that water volume going into your garden at those points.
So would you start off, say, like have kind of a target, like I don't want to get above 80 degrees, I don't want to get above 60% humidity, have some kind of target and try to get in there, and then kind of work from that to see what works better, what doesn't?
Yeah, again, it's about knowing what your plants are.
So your community of people that have done this stuff before, maybe your local grow store, give you some ideas of what to do.
Absolutely, because we could talk about higher temperatures. Some cultivators can grow at higher temperatures, and some cultivators can grow at lower temperatures, right? All depending on the cultivar, all depending on whether or not you're using CO2. You wouldn't want to use something such as CO2 and waste it if you're not running at those higher temperatures. So
it's just cool.
Yeah, it's just you're just wasting it. So in the most part, the same thing can be said about dehumidification, right? So the higher temperatures help dehumidification systems. So lower temperatures kind of reduce their capacity and efficiency as those temperatures drop. So when you stay in those ranges, every dehumidifier has a rating.
Okay.
Our dehumidifiers are rated at AHAM, which is 80 degrees Fahrenheit and 60% humidity, and so at those conditions,
you could be fighting against yourself, trying to bring your temperature down, and you're actually bringing your humidity up, or these sorts of things. Yeah. Is that what you're saying?
Yeah, but I think most growers get to a point where their plants will be in a healthy temperature range throughout their grow, especially in an indoor environment. So essentially, you don't run into those issues all too much with the temperature variance with an indoor, like a well-sealed system, an HVAC system. Where you do run into those situations is more so in the greenhouse environments, when they don't have a really conducive, like, solid way for the drop in temperature at night.
Sure.
They don't have enough heater that's giving enough to output to keep the greenhouse warm enough, and so then you get into trouble where your greenhouse temperatures drop too far down, and you get the spike in humidity. You get dew that forms on the plants.
I was in a greenhouse just a month or so ago. We were hanging out, and it started raining, and it's like, it's cold. It's a greenhouse the outside temperature and the outside things affect big time what's in there, whereas if you're in a house, not so much.
Yeah.
So okay. So those are if someone growing in an indoor type environment, you can kind of shoot for a stasis, a basic thing. Whereas when you're maybe an outside greenhouse kind of thing, you've got a lot more factors to be involved. That you may be in bed asleep, and your temperature and your humidity have dropped or gone up vastly, and so you have to be more aware of this. Much more difficult environment.
Yeah, in a solid residential structure, you don't have really Typically, you don't have the problems that you see in the greenhouse situations. Again, it's about seal. And so let's say, for example, if you're a basement grower, if you have a solid sealed foundation versus like some of these old homes with a field stone, if you find one of those homes with the field stone is going to be a leaky basement, and you're going to permit a lot of groundwater into your basement,
which is moisture.
Which is a moisture load. So understanding your basement moisture load, if you're doing a basement grow versus a closet grow, just understanding that.
Sure.
And understanding whether or not you have whole home HVAC, if that basement of yours is getting heat during those cold months. It doesn't get warm enough down there because maybe it doesn't get warm enough down there. It could be akin to like a greenhouse situation, so you don't have enough heat in that environment. But for the most part, if you're running HID lighting, unless you're running the CMHs, the LECs, which, but if you're running the higher wattage HID lighting, you typically get a good heat load from those lamps, depending on the square footage that you're that you're in. So. But yeah, I mean, there are various things that to consider with dehumidification. But indoors, it's primarily straightforward. It's what your temperatures, your ambient room temperatures, what you're shooting for a target temperature given the space, whether it be propagation, whether it be vegetative stage, whether it be flowering stage, or the final couple of weeks where you do your a late flush.
Sure.
And then your target humidities. That's all. Those are important factors in water volume. So those are the most important factors. We can get into things that, hey, I don't know any of those, and I can, if someone needs a rough estimate, very rough estimates, then we can get into other other factors to take a look at. But I primarily don't like talking about those and giving them up because a lot of people then start living by those factors.
That's the number.
Yeah.
I guess that's the thing with a lot of this stuff is a happy plant, and knowing what a happy plant looks like is get you a long way toward that, and trying to figure out in your mind of what he's not happy. What happened here? Why? Was it the humidity? Did it get too hot? Is something happening at night? That kind of thing. Does that make sense to you?
Yeah.
Okay.
And then like we were talking about we were talking about different temperatures. Like if you're growing in the in the wintertime, maybe the winter temperature affects your home more or less, or the summer temperature.
Well, sure, like when I know that my house is a fairly new house with a nice HV. I've got air conditioning and I've got heating, but I set that thing at 70. 70 is a lot different in the summer than it is in the winter. It feels colder. I assume that's the humidity a factor in it. Yeah. And it's no different for your plants like that. That you can't totally seal that anything, and so you do have a different setup at night versus day, and winter versus summer.
Sounds like you need a dehumidifier for your home.
I think I need a dehumidifier for my home.
But when we're talking about plants, I want to clarify because we started talking about the heat loads on the commercial systems. It is really of benefit, especially at nighttime. So when you look for dehumidification systems, really do the apples to apples comparison. We had mentioned that 80 degrees Fahrenheit and 60% relative humidity, and
also I just threw those out. Is that a good number?
that's a good number, and that's a good number because that's the best standard in our industry right now for dehumidification ratings. And that's what our DHUs are rated at. Some DHUs are rated at higher temperatures and higher humidities, and it's very it's akin to taking your dehumidifier and putting it in the most successful position available, and saying, okay, look, it's producing a lot of water. Well, there's a lot of water afforded to it. Okay. So when you rate at a lower temperature, a lower humidity, and you can pull the same amount of water, then we're talking about something that's a little more commercial grade.
So if I'm doing some weird temperature, I could be really tormenting my unit. So let me ask you that. If I go 90 degrees instead of 80 degrees, does this have to work harder or easier?
No, so if you go 90 degrees instead of 80 degrees, this is actually going to pull more water for you.
So conversely, if I'm keeping my room at 70 degrees with my air conditioning, I'm making this work harder. So I'm air conditioning and I'm running that thing, and I'm making this work harder as well.
Yeah, so you would push the DHU to work harder. The DHUs will, they're basic coils, right?
Yeah, sure.
It's the same technology that AC systems are based off of. It's a refrigerant-based system. They're cold coils, and there's only so cold the coils can get before the coil becomes ice, right?
Sure, yeah, and then you're done. Yeah,
and then you lose capacity and efficiency. But that's the thing versus dehumidifiers made for residential, made for basements.
Oh, very different kind of situation.
So these are made for garden market applications. These are made for grow rooms and greenhouses. do they still have the fundamental flaw that all coil? Yeah, of course they do. But this is
built for this situation versus that's built for keeping your basement dry to get mold out of it.
Yeah, yeah. So in those basement situations, those dehues are more easily, more readily affected by the drop in temperatures.
Sure.
Versus using a Quest unit or commercial grade type of dehumidification system.
Sure.
The other thing that lends into this, and we'll get back to heat loads, but when you do the apples to apples, it's not just that rating that we talk about 80 AHAM 80 and 60, but we talk about the efficiency too. So what can the dehu do per kilowatt hour? And that's the big saving, the saving grace, the saving point of having a high quality guarded market dehumidifier, whether it be like for micro grow or that 70 point I mentioned before, versus having that having the hardware store type dehumidifier, some of these big boxes, that the efficiency with our units is built into it. We have obviously technologies that have created these efficiencies, and you're not going to get that.
It's not that you're just going to work that
definitively, because
you don't know.
You just don't know. So,
but it's designed for a very different task than this is, and not only will you probably be overworking it, but you're also not going to be getting the efficiency and getting the use out of it that you would of this kind of a unit.
So the efficiency, especially in our 5 series, they're the more commercial units. I mean, all our units have great efficiency built into them, but when you get into the more commercial grade units like the 5 series or new 506, the efficiency is tremendous over a 110 or a 150 or the 70 plane. But for more home-based applications, that 70 plane or even more, one of these 110s is still not too shabby. It's still more efficient than what you find in a lot of these big box chains. Plus, you get the longevity with it. So again, you'll be saving yourself cost in the long run running an efficient unit. I mean, pints per kilowatt hour. So look at that pints per kilowatt hour value. That's also another number to take a look at when you're comparing that.
Oh, so not just last longer and be better, but also more efficient as far as not using as much power?
Not using as much power.
Oh, because so the efficiency comes in not just in that you're running it too hard. It comes in that it's costing you more money to use one of those little units that you would think would be cheaper because it's working harder, using more electricity than this would.
So, a couple fold. I mean, again, you get quality, you get the 5-year warranty with the unit, peace of mind, you have quality with it. And the other thing is, it's commercial grade, and so you get the longevity with it, and the efficiency piece. So, yes, obviously with the Quest Pro is going to pay more up front, but you're getting what you pay for when you get it. You get the longevity, you get the efficiency with it, and that efficiency is going to save you again over the long term, over the long haul, that cost of ownership with the dehumidifier versus getting a big box store.
Well, let me ask you this: when the one at the big box store breaks, you repair it by throwing it in the garbage and getting a new one. I would assume that something like this is more of a repairable type thing when it does break down. So, it lasts longer.
So
as far as that too.
Nobody's perfect. Everybody has a failure rate, right?
Sure,
but again, it's rare for them to go down, within the life of the warranty. That's why we warranty it for 5 years.
But if going past that 5 years, does it kind of run its course at 5 years, or is it something you keep going? You just do have some breakdowns, kind of stuff to it, or how do you feel about that?
We've had a lot of units surpass the 5-year mark. I mean, there have units been out on the market. God, I can't even put it into numbers for how many years, but have surpassed that 5-year mark. I mean, as far as repair and warranty work, over the 5-year on this is bumper to bumper. So if something happens, give us a call. We don't give you any. We help you troubleshoot through it, right?
Yeah.
Our tech support, like I said, the customer service and tech support is phenomenal. So we'll help you troubleshoot through your.
Oh, really? So I may be able to fix it myself.
The problem, if it can be done on site, typically if it's something small, it can be. Then we'll troubleshoot with you over the phone.
Okay.
If it's a small part, we'll send you a small part.
Right.
If you're handy. if you're uncomfortable with that, then by all means, like, if we troubleshoot it all the way through and we've found that we've discovered that it needs to be sent back, then, we take it back to we take it back to the facilities, the factory, and, our tech support, they dive into it, or repair it, yeah.
So that's another thing as far as bigger grows. It occurs to me that it might be better to get 2 of these instead of one of the bigger ones.
Oh, absolutely. So that's one facet that's a great question. It's one facet that I talk about at length when I talk to cultivations, when I talk to shops too, on dehumidification education, is it's always better to have multiple units, smaller units, than to have one.
You have some redundancy.
Because you have redundancy, absolutely. So think of it this way: if you have one larger unit and that larger unit goes down, well, there goes down your primary. There goes
You're done.
Primary source of dehumidification.
Yeah, you got a problem.
But if you have, let's say, 3 smaller units, right, then
you may struggle, but you
might struggle, but so you lose one of those units. Now you're at 2/3 capacity instead of no capacity. Yeah, so it's also better to do that. And from a standpoint too, redundancy is good for microclimates. So having the one larger unit handle a pocket of air. Is not as well. We found that as having multiple
spread out. Okay.
Reducing, mitigating those microclimates and working on microclimates. Of course, it takes a whole system. You need air movement, right? We talked about the stagnation before. You don't want any stagnation in your room, so that's why at your canopy level, a lot of cultivators or commercial growers have fans going even at the home level, right? In your home personal gardens, you have some sort of air movement. It's important to have
so that you have an even environment overall.
Your plant. You're mixing those pockets of air, and then again, you're not creating those microclimates from leaf to leaf, because you can have pockets of humidity from one leaf to the next leaf if you don't have that, quite that air movement to mix that pocket.
Well, let me ask you about that. You got the air mover over here that is, I think most people got a fan up on their wall going back and forth. This is something where it is down on the floor there and pushing the air up. What's the thinking behind that?
So the F9, this air mover, is primarily, let's bring it up here, you're right. The F9 air mover is primarily for under canopy air movement.
And it would sit flat. You can sit it flat and it would be blowing up.
No. Actually, it pulls in through the top and exhausts in the bottom. But you can redirect it. You can tilt it. You can tilt it up and to exhaust up, and you can tilt it on its side. As well,
depending on what you're trying to accomplish.
Yeah.
Okay.
But with this, the thought behind this was for under canopy CO2 uplift. So obviously CO2 is a heavier gas.
Sure.
And you don't want it to settle. You want to make use of it. So
this is not about air movement. This is about getting your CO2 up. Well, it is, but it's also about your CO2 so that you can get more to the plant to grow faster.
It's about both. It's about preventing stagnation below your canopy and preventing your CO2 from settling below your canopy. So you want to be able to uplift to have it back up. And the concept between the ground, these ground units, is to tumble the air below your canopy. So you get air mixture below the canopy. So everybody, you create that between the fans that you have at your canopy and the air movers below your canopy. People talk about a vortex. Essentially, you're getting air movement to prevent stagnation, to uplift CO2, to mix the CO2 back up into your canopy.
Okay. So you'd still have your ones up on top, but you'd also have this underneath.
Yeah.
Okay.
Yeah.
So that's I wanted to ask you too about this before I forget. Is there maintenance involved with one of these units?
Sure. Yeah.
Well, what's that look like?
Maintenance is fairly simple. I know it might be if for someone with hanging the units, it's a little trickier. You got to get up to the unit. But maintenance is really simple. I got a lot of guys ask me, do I blow anything in the coils or do anything with the coils? No. We recommend that you change out your filters every 3 to 6 months on the units. And I recommend, in addition to changing those out, or another thing is it could be every 3 to 6 months, for the filter, or at the end of your growth cycle, whichever is sooner. You want to get into a good rhythm. I typically recommend 3 months. more frequent maintenance applications sticks better than waiting half a year to change your filters.
So is that filter filtering this unit to keep it lasting longer, or is that filter filtering my air, or both, or what's the filter do?
Yeah, so you want to change those filters out, but obviously for many reasons. The filter is capturing particulate matter in your environment. The filter is preventing stuff from getting into your dehumidifier.
Sure.
So you want those filter changes to have upkeep on your dehumidifier. You don't want to you don't want to maintain particulate matter. You want stuff getting into your dehumidifier. The other thing is changing a filter out reduces restriction, right? So if you got a clogged filter, makes it work optimally where it should be working. So if you don't change your filter out, you're putting a restriction on your dehumidifier. You need to change your filters out. 6 months is okay. 3 months is better. I mean, people.
Well, in your environment too, I would assume. If you're a real dusty type area or whatever or something, it'd be different than if you're in a not so dusty.
That's a good observation too. I've seen things when I go back for training to HQ. I've seen things where filters come in the environment. Guys go through filters every month.
Oh wow!
Again, know your situation, your growing environment. It is possible for you to go through filters faster than our recommendation.
So now, does it run all the time? Is the fan always running in this thing 24/7, or does it only run when it turns on?
The fan runs when the unit turns on.
So if you were using it more, it would also, obviously, the filter would clog up more if you were working the unit harder than if you had. You might have a thing where your humidity's pretty good, pretty close, and so you're not using this as hard as somewhere where you're fighting it.
Yeah. On things and applications when the dehumidifier is undersized, sure, you're going to get a lot more. You're going to get a lot of runtime. It's not going to stop running because it
never gets there.
It never gets there.
Oh,
it's always going to try and get. It's going to try and get you where it needs to be. But if you're undersized, it's just going to keep on running and running. And that was a point earlier. I keep on forgetting the heat load on the units is a tremendous benefit. So when those lights go out and this heat load is essential in many gardens. We consider it supplemental heating. It's beneficial to gardens, and the plug-and-play systems are the systems that offer that to gardens, is to have that supplemental heating. It's it's beneficial too in greenhouses. So in the larger with the larger commercial units, having that heat load at night, it is essential many times to keep the greenhouse temperature up. Not just with the heat system, it could make your heating element at night more efficient as well. So when we're talking about the efficiency of the dehumidifier, also realize that you're efficiently getting heat into that environment as well. Supplemental heating.
It's coming in for free, basically. It's part of the system.
That brings into the point of heat into your grow environment. So when you're sized right, again, we talk about efficiency. You're going to do more with less. So your runtime per kilowatt hour, because again your unit's more efficient and is running, does more with less over that. It effectively affects some of that heat load too. So you have a diminished capacity heat load. Now I'm not going to say it's like tremendous, but
it is a factor.
It is a factor. So that too is something to take in consideration. But supplemental heat from the dehumidifier has a drying effect to it. It's beneficial in potentially making your reheat system or your nighttime heating element more efficient.
When your lights are off,
when
and
your
you're
lights
cold.
Yeah. And we do make a cooling type system, a cooling dehumidifier. But I feel like that's very situational because
odd circumstances where
circumstances. Yeah, I mean if you can use it, by all means use it. I've been recommending it more so in hotter, drier climates.
Sure.
So they're using some of that cooling element more so as an AC. I also recommend it in situations where, okay, look, we're maxed out at our panel. I really need dehumidification, but I can't afford.
Right. You're right. You don't have enough. You can't run more power through your circuits.
So running the 185 pool could be an option for you because it's not putting more heat in. But it's the converse now. During the nighttime operation, you're going to be using more of your heating element because now you have a cooling element that's dehumidifying. So you get about a third ton. It's not much. It's a third ton of cooling within the environment. And so Some guys find it beneficial. They don't mind the cooling, and
Uh-huh.
so they don't mind the extra runtime that they get from their heating element at night. So, but that's just one. You're not getting the heating element from the dehu at that point to give you efficient supplemental cooling.
Sure.
You're getting a cooling aspect of it. So.
Okay. Well, very cool. Well, I think we covered quite a bit. I appreciate you going into more in depth. A lot of times when you do these things, you get little short elevators, this pitch, and that's it. So I think people are real interested in that. If you could come back, from time to time and talk to us, that'd be super cool.
I'd love to.
All right. Well, thanks.
Yeah. Well.
That's the show. Okay, that was fun. I'm glad you stuck through the whole thing. I'm happy. I'm a little surprised. I don't know. Was it good? Was that interesting? Let me know in the comments what you thought about that. And also, Santo is on board for coming back for any kind of information that you all might want to have about anything involving environmental type controls. So, questions in the comments. Thanks for watching. I love you, and I'll be back tomorrow. We'll do something fun. For more information about anything on today's show, go to our website, OCGFAM.com. And if you buy anything while you're there, use the code OCGFAM2018. It's going to save you 20%. The OCGFAM show, it's pretty good. It happens every day. It's the OCGFAM show. See you tomorrow.